Assalamualaikum warahmatullahi wabarakatuh. So we from group 2, we have 2 members. First me, my name is Clarisa Millenia Zainal Putri, and the second member is Febi Indriana Fitriasari. So we will explain about recyclable material classification by using convolutional neural network.
Okay, first of all, I will try to introduce myself. My name is Febi Indriana Fitriasari. Now, I want to talk about recyclable material, convolutional neural network or CNN, and training data with CNN. And the first section is recyclable material. Recycling is the process of converting waste materials into the new materials and objects. Recyclable materials include many kinds of glass, paper, cardboard, metal, plastic, tires, textiles, batteries, and electronics. Materials to be recyclable need to be sorted and reprocessed so they can become new materials for the manufacture of new products. In this case, we use the two kinds of recyclable material. There are aluminum can and PET bottle. The next part I want to explain about convolutional neural network or CNN. Convolution neural network or CNN is a machine learning method from the development of multi-layer perceptron or MLP, which is designed to process two-dimensional data. In general, CNN takes advantage of the convolution process by moving a convolution kernel or filter of a certain size to an image. The computer gets new representative information from the multiplication of parts of the image with the filter used. Or the other word, convolutional neural network is widely used neural network architecture for computer vision related tasks. Next, I want to explain about architecture CNN. CNN is composed of two major parts. There are feature learning and classification. In the feature learning, divided by convolution, value, and pooling. And for classification, is divided by flattened, fully connected, and softmax. Convolutional layer will encompasses filter and feature map. And for ReLU or rectified linear unit is to introduce nonlinearity our CNN. And for the pooling layer, would to reduce the number of parameters when the image are too long. Spatial pooling can be different of three types. There are max pooling, average pooling, and sum pooling. For the classification, the fully connected layer will serve as classifier on top of this extracted feature. It will assign the probability for the object on the image being what the algorithm predicts it is. Okay, next I want to explain about the kind of architecture of CNN. First, there is AlexNet. AlexNet was one of the first deep networks to push ImageNet classification accuracy by a significant stride in comparison to traditional methodologies. AlexNet, proposed by Alex Krzyzewski, used ReLU or rectified linear unit for the non-linear part. instead of a tan or sigmoid function, which was the earlier standard for traditional neural network. Next, there is a VGGNet. This architecture is from VGG Group in Oxford. It makes the improvement over AlexNet by replacing large kernel size filter 11 and 5 in the first and second convolutional layer respectively, which the multiple 3 times 3 kernel size filter one after another. There are multi-variants of VGGNet, such as VGG16, VGG19, and etc., which differ only in the total number of layers in the network.
So the next architecture CNN is ResNet. ResNet Residual Network. Residual network allow training of such deep network by constructing the network truth module called residual model as sounds in the figure. It essentially means the early layers are almost negligible learn. This is called vanishing gradient. So this is next. This is we have inception. Inception module consists of 4 operations in parallel. First is 1 times 1 convolution layer, and the second is third time third convolution layer, and the third is 5 times 5 convolution layer, and the next is max pooling. The first time the 1 times 1 convolution blocks shown in yellow are used for the fat reduction. The results from the 4 parallel operations are then concatenated stepwise to form filter concatenation block in green. There is multiple version of inception. The difference between AlexNet, ResNet, VGG, and Inception. VGGNet not only has higher number of parameters and flops as compared to ResNet, but also has a decreased accuracy. It takes more time to turn a VGGNet with reduced accuracy. Turning an AlexNet takes about the same time as turning Inception. The memory requirements are 10 times less with improved accuracy, about 90%. ResNet but have about 60 million parameters, but there is about 1000 difference in their top 5 accuracy. But training a ResNet requires a lot of computation, more 10 times more than of AlexNet, which is mean more training time and energy required. So the next part is training data with an N.
Okay, next I want to train the data of recyclable material, can and PET with the CNN using Google Colab. First of all, we must to connect our Google Colab to Google Drive. At the beginning of creating the program, we will get the link that will direct us to the Google account, which link to the Google Colab. Then we must to import the file location to Google Colab. In this case, in my Google Drive, there is a folder which name is Assignment 2, and in the Assignment 2, there is a file that name is Recycle. After that, we create the train and validation data directory. In this program, train_dir will show the location on our Google Drive, which is used for training data, and the validation need is a program that will show the location on Google Drive that is used for validation data. Each training and validation consists of can and pad. Next, we will create the program directory for validation and training. For train_dir, this is a program that will show the location on Google Drive that is used for training data, and the validation_dir is the program that will show the location on Google Drive that is used to the validation data. For each train_dir and validation_dir, that is consists of can and pad. In this program, we will get the length of can train is 156, length of pad train is 310, and for length can is 77, and the length of pad is 133, and the total of the length or the image of on the folder is 676. Next, we import the TensorFlow. TensorFlow is the open source library for numerical computation and large-scale machine learning. The next step, we will to construct the CNN model. In this case, we use the 4 convolutional layer. And the first convolutional layer, we use 32 feature map with the size 3 times 3, and the activation is ReLU. And second convolutional layer, we use the 64 feature map with the size is 3 times 3, and the activation is ReLU. And then the third convolution, we use the 128 feature map with the size is 3 times 3, and the fourth layer we use the 128 feature map with the size is 3 times 3. We use the fourth convolutional layer and 4 max pooling layer. After that, for the fully connected layer, we will use the flatten. Flatten will change the size of feature map to one linear line. And then we use dense layer, which is fully connected with 512 neuron with the activation is ReLU. After that, for the output layer, we use the dance with one neuron, and the activation function is sigmoid because the classification image is 2 class. So we use one neuron which will produce output is 1 or 0. Then we compile the data with the function optimizer is RMS probe and the learning rate is 0.001, where the loss function is binary cross entropy and the metric is accuracy or ACC. And then we get the parameter like this. Next, we will pre-process the dataset. The file that's saved in the Google Drive will be pre-processed in this program, starting from the image data generator, with the parameter scale is 1 per 255. It means we will normalize the RGB value from 0 until 1 because the RGB value is 255, so the scale that we use is 1 per 2055. So the scale that we use is 1 per 255. And then the batch size. The value of batch size here is 20. Batch size means that how many images are processed in one word, and then update the weight. Of course, it will give the different result when the value of batch size is 1 and 20. For the class model, we use binary because the classification image that we use is 2 class. And then we get the result like this. After that, we start the training process with the function model fit. In this case, the value of step per epoch is 10, the value of epoch is 15 and the value of validation step is 10. And finally, we get the accuracy of training is 97% and the accuracy of validation is 80%. To plot the outcome, we can use the function matplotlib and we get the result like this. This is the validation accuracy and the circle is the training accuracy. The accuracy will be equivalent with the loss function. We get the value of accuracy training is 97%, and the accuracy validation is 80%.
So next, I will explain how training data set and M by using transfer learning concept with pre-trained model. So I choose two pre-trained model with VGG16 and VGG19. So if we use without pre-trained model, we can get this code, connect to Google Drive, and then feed dataset directory, and then create train and validation data directory, and construct the CNN model. So the difference with pretend model of the difference between if we use pretend model or without pretend model is in pretend model we input or we include the dataset or library from VGG16 and VGG19. So this is the library of VGG19 and VGG16. So the construct of the end model is same if we use without pretend model. And we add this program too if we use pretend model. So in VGG16, we write the data or comment is VGG16. If we use VGG19, we change the 16 in here with 19. So if we run, we can get this result. And then this is the next code. And the next step is pre-process the input data. So the previously, if we don't use pretend model, we use this batch size and batch size. So the same with if we use pretend model. In pretend model, I use the 20 for batch session generator, and I use batch size for validation is 1. So if we run, we will know how much image in train data and validation data. So in train data we have 466 image, and in validation data we have 210 image. So the next step is we start training process. In this training process, I use a step for epoch is 10 and epoch is 15 and validation step is 10. So if we run this code, we have this is a process, and we will get the highest accuracy. So the highest accuracy if I use pretend model VGG16, I will get the accuracy is 100 and validation accuracy is 100. So if we plot the accuracy or outcome, and we get this plot. So this is the plot of training and validation accuracy, and this is the plot of training and validation loss. So in training and validation accuracy, the point is training accuracy, and this line is validation accuracy. So with this is training validation loss, the point is training loss, and the validation loss is the line is validation loss. So with VGG16, still I get the underfitting and overfitting. So the next I will show you if I use VGG19. So firstly I said if we use VGG19, we just change the we just change this. We just change the number of 16 with 19, and we run all the code. We get this model. A value of batch size and batch size validation is same with previously. And if we start the training process with VGG19, with step per epoch is 10 and epoch is 15, validation step is 10, we can get the highest performance is 97% and validation accuracy is 100. So if we plot the outcome, we get this plot. This is the plot of training and validation accuracy, and this is the plot of training and validation loss. So if we compare the plot, we will know if we use VGG 19, the underfitting and overfitting is less, more than if we use VGG 16. And if we want to get the optimal or the highest performance, the best highest performance, we can get changing the efforts or batch size of the training process. So this is the most perfectly I can get from pre-trained model, even though there is some error in the process. So the conclusion of this video is we also learn to demonstrate the ability to solve tasks and analyze the suitable algorithm based on intelligent system design. With pre-trained or not, we get the higher accuracy. If we want more, get the higher accuracy and perfectly the training, we can change the batch or number of epoch, or we can change the architecture of data, architecture and from data. So this is enough for me. So I'm sorry if any mistake. Wassalamualaikum warahmatullahi wabarakatuh.